Thank you all for joining us here, and I suspect there's some folks on our Zoom webcast as well. So good evening and welcome. I'm Stan Gerson, the Dean of the School of Medicine. It's really an honor to be here to celebrate the establishment and the induction of 2 endowed professorships in our Department of Pathology. Both reflect the remarkable care and diligence on the part of Cliff Harding, chair of the department, who led the effort to encourage establishment of both of these endowed chairs to help sustain the department, and who has sought successful financial support for the milestones needed to get to this point. So as dean, if I had more department chairs who spent their time proactively in this endeavor, I would be smiling much more of my time. So thank you, Cliff, for your leadership in this effort, and it deserves a clap. Both of the chairs we celebrate this evening were established very recently, and we offer investiture this afternoon to the inaugural chairholders. I'll start with Michael E. Lamb, MD, designated professorship in pathology. Dr. Lamb, who's with us this evening, was prior chair of the department, and he and his family are with us this evening. And we celebrate the appointment of the inaugural chairholder, Brian Cobb, and I appreciate that. Dr. Cobb leads the immunology track in the pathology department training program, and is a preeminent investigator in glycobiology of the immune response. Of equal stature is the Louis Pellimer, PhD professor of experimental pathology. Dr. Pellimer was a prior faculty member who made some astonishing discoveries while here, which we'll talk about in a few minutes. And this evening we celebrate the appointment of Dr. Teresa Pizarro as the first chairholder. Dr. Pizarro leads the R25 in medical student research and is recognized worldwide for her efforts in understanding cytokine and signal molecule mediators of inflammatory bowel diseases. And to be honest with you, I suspect that she has actually helped the discovery of many of the early therapeutics that are still needed in this space. So I'd like to extend a thank you and a welcome to Dr. Lamb, David and Stephen Pellimer and their families who are here to celebrate with us, both Drs. Pizarro and Dr. Cobb. So thank you for joining us. For those of us who live outside the world of academic medicine, it's sometimes hard to understand why we value professorships as much as we do, and we certainly do. There are more than 125 endowed professorships in the School of Medicine. We could use a few more. We offer professorships through the generosity and trust of our alumni, our friends, and individuals who come to know our university and our School of Medicine, and sometimes, as this evening, as Dr. Harding will mention, through the efforts within the school itself and resources that we think can provide support for. But most importantly is the dedicated faculty who accomplish so much that their deservedness for a professorship becomes so obvious to us as many in the Department of Pathology. And they also help us globally with the mission of the School of Medicine, which is to improve global health by linking research to populations in a superb educational environment, which we have here. So it is my pleasure to offer a little bit of time to the department chair, Dr. Harding, whom I mentioned. Dr. Harding himself is the Joseph B. Cowan Professor and Chair of Pathology, Director of the Medical Sciences Training Program, a member of the Case Comprehensive Cancer Center. If he doesn't have enough time, he's also a good educator. So, Dr. Harding.
Thanks, Dan. I'd like to first introduce the professorship, the Michael E. Lamb Professorship, and Dr. Lamb, and then say a few words about Dr. Cobb. Mike Lamb did his undergraduate work at Amherst Medical School at University of Rochester, and then came for his first appointment in our department as a resident in pathology from 1959 to 1962, and then spent time at the NIH and then as faculty at NYU, where he rose to full professor, and then came here in 1981 to Case Western Reserve University as professor and chair of the Department of Pathology, which he led for 2 decades, and then stayed on as faculty in the department until 2007, and continuing to this day as one of our emeritus faculty members. He received honors too numerous to enumerate here, but I will mention his service to the American Association of Pathology, now known as the American Society of Investigative Pathology, which his service included serving as counselor, vice president, and president of that organization. And in 2004, he received the Gold-Headed Cane Award from the ASIP, which is the oldest and most prestigious award of this society. He's on numerous other advisory boards and committees for the NIH and other organizations. He published over 190 research publications in Cell, Journal of Experimental Medicine, Journal of Clinical Investigation, Journal of Cell Biology, Journal of Immunology, Proceedings of the National Academy of Sciences, American Journal of Pathology, Journal of Biological Chemistry, Laboratory Investigation, and others. His research centered on immunoglobulin structure and function, particularly IgA, mechanisms of nephritis, IgA transport, and mucosal immunology, including novel models of transcellular and intracellular IgA transport and function. During his time as the chair of our department, Mike built a tremendous program that fulfilled the triple mission for clinical, educational, and research excellence. National and international experts were recruited in many areas. When I came to the department in 1993, the department was ranked 4th in the United States in NIH funding, a truly amazing accomplishment. In research, Michael developed the 3 focus areas for this department of immunology, cancer, and neurodegeneration research, and those continue to this day as our strategic focus areas. And finally, on a personal level, Michael served as a very kind and supportive chair to me and many other faculty. I'm forever grateful for that support, and I know that many others are as well. So I want to recognize Dr. Lamb for his achievements and thank him for his contributions to our department, the support of our faculty, and now his generosity in establishing this professorship. In addition to the major support provided by Dr. Lamb for this professorship, a number of his colleagues and friends also contributed to the professorship in his honor, and I know that they're also celebrating this event. So it's a special treat also to have Michael back in Cleveland, accompanied by his daughters, Meg and Jocelyn. It's given us a chance to reconnect and celebrate this event. So thank you, Michael, for all your generous support and all your contributions to our department and our academic community here. So I'll now turn to our inaugural Michael E. Lamb Professor of Pathology, Dr. Brian Cobb. Since Dr. Cobb will be presenting, I'll keep my description of his work and accomplishments short. He'll have time to discuss those projects. Dr. Cobb received his bachelor's degree from University of Oklahoma and his PhD from Washington University. He did a postdoc with Dennis Casper at Harvard with a year of appointment as instructor at Harvard. And he joined our department in 2005 as assistant professor and rose to his current appointment as professor with tenure in pathology. His research programs focused on the crossroads of immunology and glycobiology, including T-cell recognition of carbohydrate antigens, novel paradigms, effects of antibody glycosylation on antibody function, and other areas that he may discuss. He's been well funded with numerous publications, including publications in journals such as Cell, Journal of Biological Chemistry, Glycobiology, Proceedings of the National Academy of Sciences, and others. In addition to his NIH funding, he received a prestigious 2015 Hartwell Foundation Individual Biomedical Research Award. He's been an important leader nationally in the immunology community and in the glycobiology community, and numerous leadership and service awards. Too many to mention here, but I'll just say won the Distinguished Service Award by the American Association of Immunologists. An amazing thing about Brian is his incredible commitment to graduate education. He's a fierce proponent of student interests, and he's an incredibly dedicated teacher. And as a result, he's received numerous teaching recognitions. The 2019 winner of the Dieckhoff Award for Distinguished Graduate Student Mentorship. That's a university-wide award, not just within the School of Medicine. And also a nominee or finalist for that award in previous years, and also the Dieckhoff Award for Distinguished Graduate Student Teaching. And importantly, in 2016, he received the Michael E. Lamb Award for Excellence in Graduate Teaching. This is extremely fitting because Dr. Lamb was very dedicated to the success of our training programs and our PhD students. Dr. Cobb's also the director of the Immunology Training Program, as Dean Gerson mentioned, and PI of its NIH T32. Does an incredible amount of teaching and student advising and mentorship, as well as important leadership in the pathology graduate program. So let me close in congratulations and appreciation for both Dr. Lamb and Dr. Cobb. Thank you.
I believe I get to invite Dr. Lamb up to say a few words. I have known Dr. Lamb since I arrived here a little after he did in 1983, and watched him build an incredible department of pathology. And it's odd for me to see him sitting in the back corner, since he always occupied the front row at every seminar I ever attended with any pathologist in the room. So Dr. Lamb was very incredibly well regarded by the entire faculty of the School of Medicine, let alone his department. Dr. Lamb.
Thank you, Stan. About 3 years ago, Pam Davis, when she was the dean, approached me and said she had been discussing with Cliff Harding the possibility of setting up an endowed professorship in my name, and wanted to know if I would support such an effort. So I told her I would like to think it over for a while, and which I did. I discussed it with my daughters, and we all agreed that that's something that would be worth supporting. So the funds were raised through the efforts of the School of Medicine and some contributions from myself, and the professorship was established, and Cliff Harding said that he would like to appoint Brian Cobb as the first Lamb Professor of Pathology. And was that okay with me? Well, you've heard what Brian's accomplishments have been. Cliff filled me in with what Brian has done for the department, for the school, and for the research community nationally and internationally. Brian joined the department a few years before I retired and moved to San Francisco, so I was delighted on two scores. A, that Brian had done so well as a scientist, and B, that I actually knew him personally and remembered him with a great deal of fondness. When I came in 1981 as the new chair of pathology, there wasn't a single endowed professorship in the department. The first one occurred when Joe Kahn, who had been the chief of pathology at the VA hospital, died and left his estate to the department. So the Joseph R. Kahn Professorship of Pathology was set up. That was the first endowed chair in the department. And I must say I've been very impressed and delighted with the number of endowed chairs there are now, and I think that's a great testament to Cliff Harding's entrepreneurship and dedication, and together with the support of the School of Medicine administration. So I would like to thank Cliff and this School of Medicine administration for setting up today's events, and I appreciate Stan Gerson's taking the time from his busy schedule to be here and preside.
And to offer, if I could, we decided that you probably didn't need another chair in your house, but you might enjoy a bowl that says the Michael E. Lamb, MD, Professorship in Pathology, April 18th, 2023.
Thank you very much. Yeah, I think that would be safer. Thank you.
I am occasionally brief with my introductions, which I will be for Dr. Neil Greenspan, because he would like to spend his time with a formal introduction of Dr. Brian Cobb as the professorship holder. Dr. Greenspan and I have known each other since I was a fellow at the University of Pennsylvania, and his spouse was the secretary for the chair of our division of hematology. Dr. Greenspan is a professor of pathology and director of the histocompatibility and immunogenetics laboratory for Cleveland Medical Center. And again, a front row sitter in the department at every seminar, and always asking a better question than I can even imagine. Neil.
Thank you, Stan. On this celebratory occasion, my task is to be swift in delivering the gist without excess grist. I begin with a brief bit of historical context. Through this ceremony today, we carry on a tradition that dates back to Marcus Aeneas Verus, whom the scholarly Mike Lamb may recognize as Marcus Aurelius, Stoic philosopher and emperor of Rome from year 161 to 180 of the Common Era. In 176 CE, or AD as you prefer, the emperor established a series of endowed professorships in philosophy in Athens. More than a millennium later, in 1497, King James IV of Scotland endowed what may be the first professorship of medicine at the University of Aberdeen, beating roughly by half a century endowed chairs in physic, as medicine was known in those days, at both Oxford and Cambridge. The various pictures on that slide will make sense by the end. We are fortunate today to be honoring two colleagues, Brian Cobb and Teresa Pizarro, by conferring on them endowed chairs created by and/or honoring actual researchers, and even better, researchers of major impact. Michael Lamb, as you all know now, is a former chair of the department, served in that capacity slightly longer than Marcus Aurelius was the emperor of Rome. And Louis Pillemer was a member of the department in the 1950s. I don't know if he started in the 40s, but he certainly was in the 50s, and discovered the alternative pathway of complement, which is extremely important. That is a fact, not an alternative fact. In my eyes, professorships in honor of researchers are to be especially applauded. You may applaud. Now let us turn to Professor Cobb. He is a native of Oklahoma and claims, through his paternal lineage, Cherokee heritage, specifically membership in the Western Band of the Cherokee Nation. He began his journey in higher education in his home state of Oklahoma at the University of Oklahoma. There, his scientific interests surfaced sooner rather than later. most people don't know the slogan of the University of Oklahoma football team. There, he was an undergraduate research assistant in the laboratory of Richard Cummings, a biochemist interested in the enzymology of carbohydrate synthesis, perhaps foreshadowing his later preoccupations. I will note in passing that glycans are arguably the most underrepresented and undervalued of biological macromolecules in comparison with the attention-seeking nucleic acids and proteins. Brian continued up the academic slope with graduate work at Washington University and postdoctoral training at Harvard, as was already briefly mentioned. In the former experience, under the aegis of Mark Batrash, Brian focused on alpha crystalline and its interactions with membranes and cataract formation, and at Harvard, in the lab of Dennis Casper, he resumed his investigation of glycans in the study of polysaccharide A of Bacteroides fragilis, and initiated what would become his long-standing engagement with immunology. A seminal finding from this body of work was Brian's demonstration of the ability of class II MHC molecules to bind and present a subset of polysaccharides to T cells, a concept which was entirely novel. In 2005, Brian joined Case as an assistant professor and began his academic ascent, if not towards heaven, then towards the status being conferred on him this afternoon. As a faculty member, Brian has energetically pursued glycan-centered immunologically relevant research, teaching primarily of graduate students, as noted, and actively contributed service of diverse types to the department, the university, and professional organizations, most notably the American Association of Immunologists and the Glycobiology Society. On the left over there, you see Brian holding up a, I don't know if it's a book or a magazine.
Yeah, it's a copy of Essentials of Glycobiology.
Okay, so he is holding up one product of his scholarship. And here he is celebrating perhaps his most important achievement, the victory of his lab in the charades contest in the holiday party this past Christmas. And there we have two of his graduates. He has a number of non-research achievements, which have already been mentioned in part, but he created 2 courses de novo, to use Brian's term. He received the Distinguished Service Award for the American Association of Immunologists and some of these other phenomenal honors. And this is just a brief sampling, a representative sampling from a longer list. Obviously, Brian's going to fill you in on his research accomplishments. I will briefly note that with respect to his service and teaching activities, they are extensive and substantive, and you got a sense of that from the slides. Now, in what I call the vector theory of academic achievement, the axes of achievement are presumed to be orthogonal. In this framework, distance from the origin is the coin of the realm. I leave you all to contemplate and admire Brian's n-tuple. For those of you not familiar with the term n-tuple, that refers to the coordinates along the various axes that define Brian in this theory of academic achievement. On the final slide, I offer a partial list of Brian's virtues as I see them. He is related in his approach to life a little bit to Marcus Aurelius, who was, I mentioned, a Stoic philosopher, in that he understands that one must remain committed and continue on even in the face of adversity. He's serious like Marcus Aurelius was, but has a sense of humor, as has already been made apparent just in these past few moments. He's concerned about the welfare of others, especially students, and is dedicated to teaching and the broader educational and professional mission. He strives for scientific rigor. That's one of his most notable characteristics as a colleague. And he's also committed to clear and incisive scientific communication, a point that was emphasized by the great physicist Niels Bohr, who was also a philosopher, the intellectual sparring partner of Albert Einstein and mentor of Max Delbruck. He's an exemplar of the concept from Jain philosophy, which many of you may not be familiar with, called anakantavada, which is meant to convey non-one-sidedness or many-sidedness or no one perspectivism. And this is similar to some degree to Bohr's concept of complementarity. And I'll just note that among his dimensions not on the 3 axes of academic achievement, he's a talented musician, a trait he shares with Dr. Lamb. He's a master scuba diver. He is skilled in the arts of construction in multiple domains, and apparently he likes to lay tile. And least expected from me was that he has expertise in dog grooming. And with that, I give you the man of the hour, Brian Arnold Cobb, AKA the Lamb Professor. Or if you will, Professor on the Lamb Chair.
I have no idea how to follow that. And Neil, when I said roast, I meant for dinner, not. Wow. Okay. So I'm not going to talk about my research achievements. I decided to take a bit of a different tact with what I'm going to spend my 10 minutes with. So I was given this slide deck of suggested slides of, hey, how did you get to where you are? Tell us a little bit about yourself and your background and that sort of thing. So I am going to emphasize that part of the story and not so much the research part of the story. So, right, so when you work in glycobiology, almost everyone outside of glycobiology feels the need to make jokes about glycobiology being focused on sugar. So I decided to play that up in my title here. But yeah, so I want to start out with, at the very beginning, actually, I'm going to even go back before that. So the only reason I'm standing here today is from the get-go, the support that I have always had, both at home, starting with my parents who just expected me to do great. There was never any pressure, it was just expected. That was, you're going to do great things, you're going to go to college, you're going to get a college degree, and it's going to be awesome. And so there was always that support, and that support has always kind of followed me through my entire trajectory. And that started with this man right here, Gary Stout. So I can't think of him as Gary Stout, it's Mr. Stout. So Mr. Stout was my high school chemistry teacher. So heading into high school as a junior, I really didn't know what I was going to do. I was thinking, okay, maybe I'd major in music or something like that, but I couldn't figure out how I could possibly make a decent living playing music without a huge dose of luck, and I just was never very comfortable with that. So I walked into my junior year of high school, into Chemistry 1, and met Mr. Stout. And Mr. Stout, in the course of about 3 weeks, introduced me to chemistry and influenced me and inspired me to go into science. So from the get-go, right from the beginning weeks of junior year in high school, I knew I was going to be a scientist. And it's because of Mr. Stout. And he's still around. He's retired now, and I'm going to send him a link to this video, so hopefully he'll get a chance to see it. So hello, Mr. Stout. It was like, there's the before Mr. Stout and after Mr. Stout. And it was a really important moment in my education. The next person on the list was my organic chemistry professor at the University of Oklahoma. So I decided I was going to be a scientist. First year of college went by without any kind of incident, but entered into organic chemistry and immediately fell in love with organic chemistry, and made it a point to get to know Dr. Lair, the professor of the class. And through a number of interactions, he would ask me, what do I want to do? Where am I going to go? What's my trajectory? And I told him that, I wanted to be a scientist. And he's like, well, then you should be doing research. You shouldn't be talking to me. You should be doing research in a lab. And the next thing I know, he had made several phone calls, and I was paired up with the next person on the list, Rick Cummings, at the University of Oklahoma Health Sciences Center. I have a Rick fan over here. You know, and that happened. I mean, I didn't ask Dr. Lair to do that. I didn't ask him to pair me up with someone. It just happened. He just did it. And so, you know, especially coming from a background where, you know, no one in my family could tell me how to navigate scientific careers. And I mean, I didn't have any of that. And he took me and said, nope, this is where you go. This is how you take the next step. And so I worked in Rick's lab for a while as an undergrad, and it was fantastic, and that's where I got the initial bite of glycobiology. I still interact with Rick on a monthly basis through the Consortium for Functional Glycomics, he's the leader of, and I'm on the steering committee for. So I still see him all the time, even though it's been 30 years. That was 1993 when I was placed in his lab. All right, then I was off to graduate school at Washington University in St. Louis. And my mind was very much made up on, I wanted to learn how proteins worked. I wanted protein biochemistry. How do these things actually do work? How do they do things? How do they bind to things? How does this work? And so I landed in Mark's lab in the biochemistry program. And so two things happened when I entered his lab on the first day. So the first thing is I met Lori. So Lori was sitting there at a computer. Sorry, I got to tell this story. So Lori was sitting there at the computer, and she had this gigantic brownie. And she had a Diet Coke. And I immediately started giving her crap about it, because it's like, well, if you're going to have a giant brownie, you might as well go for the sugared soda, right? What difference does it make? And so this is May of 1997, and we got married the week after I graduated. She has been in my lab ever since, and I would not be here without her. She's been with me the entire way. Thank you. I love you. You're not supposed to cry. All right, the second thing that happened was I met Mark. And Mark, so before Mark, there was, you know, Rick and these other people who were very inspirational figures to me. They, you know, here's chemistry, here's organic chemistry. You should work in a research lab. This is what glycobiology looks like. So they were all very kind of inspirational, especially as I'm looking back at it now. Mark was the person who taught me how to actually do science, how to be a scientist, how to read the literature, how to ask good questions, how to formulate a good experiment, how to interpret my data, and very importantly, and I'm still working on this, how not to respond to your manuscript reviewers. I have a really tough time with that one, and he used to laugh much at my expense for my review rebuttals. Anyways, so Mark was instrumental in making me actually be a scientist, okay? And so at this point, I'd learned biochemistry, I had done glycobiology, and as you heard early on, I'm the director of the immunology training program, and I haven't mentioned the word immunology yet. So at this point, there had been no immunology at all. And I decided that what I wanted was to try to blend in my previous experiences with getting that immunology side of things. And so enter in Dennis Casper and Art Zianibus, and I'll kind of explain that in a sec. So Dennis was working with carbohydrate antigens, so complex carbohydrate antigens. So we had a commonality with the glycobiology side of things. I felt that he needed a biochemistry person to come in and do these interaction studies with MHC, and he had the immunology that he could give to me. Put those three things together, and I thought that was a really, really nice synergistic kind of a relationship, and it really worked out very well. But I really shouldn't mention Dennis without, in the same breath, mentioning Art, because while Dennis was the head of the lab and he, was the great facilitator, he brought the money in and all that, Art was the one in the lab showing me how to set up a T-cell assay, how to handle the animals, how to give injections, and all of these things, the day-to-day stuff. And without either one of them, I would not be doing immunology. So at this point, I get recruited. I get a phone call from John Lau. This is like 2004, so late 2004. I get a phone call from John Lau saying, hey, I saw your paper. We had just published the thing about MHC binding to these carbohydrates, and I just accepted the position to be chair in the pathology department at Case. I think, why don't you fly out from Boston, you give a seminar, and we'll talk. Great. So I did that. He offered me the job. I took the job, and that was 2005. And so there's two funny bits about this. So number one, I direct the immunology training program, and I've never taken immunology. And number two, I took the only faculty position that was on my radar at all that I didn't apply for. So I never even applied to Case. John just said, you should come. And I said, wow, that's a great idea. And so here I am, and it's been 18 years. So yeah, so that gets me to 2005. I know I'm like taking up too much time, but how do I get from 2005 to being on the stage? And that's the people that have worked in my lab. So this is Team Carbohydrates version 1.0 in 2005, but it's really everybody that's been in the lab over time. And it's the bottom cohort there, or the bottom row of pictures is the current cohort. I owe everything to them for making the lab actually functional, for doing the research, collecting the data, and doing all those cool things that we do in the lab. All right, I'm going to be really quick about this because I didn't want to emphasize it anyway. So as you already heard, my lab works at the interface between glycobiology and immunology, so the role of complex carbohydrates in regulating the immune response. So I would think most of you that's ever taken a biology course would be familiar with the central dogma of DNA, RNA to protein. But where my lab really fits in is what those proteins actually do. And some of those proteins are enzymes, and some of those enzymes make complex carbohydrates. And those complex carbohydrates include some familiar words to even the non-scientists, so heparin sulfate, chondroitin sulfate. So these are glycosaminoglycans, but most proteins at the cell surface and anything that's being released are also glycoproteins. We have glycolipids, so they're kind of all over the place. And so the real question is, what are they doing? And so we focus in on two things. So I've got a couple slides, and then I'll call it quits here. So the first one is our interest in IgG glycosylation, so antibody glycosylation, and this is where there's a very nice connection between myself and Dr. Lamb in our interest in antibody function and structure. And essentially what we are interested in is how those glycans that are decorating IgG, and how that impacts their function and how that's regulated, those processes are regulated. And then on the other side of it is that we're interested in macrophages. And so how do macrophages actually become the phenotypes that they are? So if you look at many different tissues throughout the body, most tissues have a cohort of tissue-resident macrophages that have a very particular kind of phenotype that's characteristic of that tissue. And so what we have discovered and what we are working on and trying to understand is that the glycans on the tissue cells, so think hepatocytes in a liver, how those glycans on those cell surfaces interact with the macrophages to drive function. And this also is applicable to the tumor microenvironment. So the big picture is, what do glycans do in immunity? That could be cancer, it could be infection, it could be therapeutics, it could be autoimmune disease, it could be transplantation. It impacts a great many different things, and we're trying to understand the fundamental molecular mechanisms that underlie its regulation. Last slide. So I really want to thank, everybody for coming. This is an amazing turnout, although I think I have Teresa to thank for the large number of people that are here. But I really want to thank Michael Lamb for inspiring, and driving this process of creating this professorship. I want to thank Cliff Harding for the support. I could easily have listed him in the mentor slides as someone that has helped guide me throughout my career here at Case. It's really fitting that Michael worked on antibodies, I work on antibodies, we overlapped a little bit, and getting a professorship named after someone that not only I have that personal connection with, but is also relevant to my research, and really is I guess a sign of and representative of scientific excellence. I'm really humbled by the selection, and I really want to thank you, thank Cliff, thank everybody for coming, and I will shut up.
You know, having the honor of giving an endowed professorship lecture, I'm always struck by how hard it is to do it and have a good time doing it. And so thank you, Brian. I'm now going to turn our attention to Dr. Teresa Pizarro as the Louise Pellimer PhD Professor of Experimental Pathology. We have the children of Dr. Pellimer here. But many of you probably don't know much about him and his remarkable contribution. So I'm going to tell you a little bit, if I could. So Dr. Louise Pellimer was born in Johannesburg, South Africa in 1908, the son of Lithuanian parents. Brought to the United States as a child, naturalized in 2016. Attended public schools in Ashland, Kentucky, and then began as a football recruit to Ohio State University. You'll notice I didn't use the the word. He later attended Marshall College in Huntington, West Virginia, and then Duke, where he received his bachelor's degree in 1932. He was accepted to Duke's medical school, scored the highest grades in the country in the National Board Part 1 at the end of his second year. Given the times just post-Depression, about which this country was still reeling, he took his call from the state of Kentucky to serve patients in rural areas, which he did for a couple of years, traveling by horseback and attending to the sick without a medical degree. He then decided to pursue a PhD in immunology and joined in 1935 the graduate program at Western Reserve University, and was offered a faculty position just after graduation. Soon thereafter, he was involved with the purification of tetanus toxin and was able to purify the antigen to pertussis. He earned his excellent reputation as a biochemist soon thereafter. In addition, as Neil pointed out and Cliff pointed out, he began to unravel the complexity of the alternative complement pathway and its activation properties. And in 1954, identified propyridin, which was somewhat of a controversial finding at the time, a plasma glycoprotein, I think we just heard about glycoproteins, induced by leukocytes that stabilize complements 3 and 5, the convertases, and therefore activated the alternative pathway, which we now recognize as fundamental to our response to both infectious and inflammatory processes. I don't think the world was ready for that incredible discovery at the time, but it has laid the groundwork for much of the remarkable work in complement that takes place worldwide, and certainly members of our pathology department, such as the contributions of Ed Menoff, who's here with us this evening. Dr. Pellimer passed away far too young at the age of 49, but his work continues to influence our everyday activities. And again, it's my pleasure to bring back Dr. Harding to tell us a little bit about both Dr. Pellimer and the rationale for establishing this professorship. Dr. Harding. Here he comes.
Thanks, Dan. So I have one little correction to make. This is a really illustrious past member of our faculty, Dr. Erwin Leapow, who worked with Dr. Pellimer. But sorry, we got the wrong picture here. So actually, I have had some remarks about Dr. Pellimer, but Dean Gerson has already covered his background extensively, so I'll skip those, except to say that the work that Dr. Pillemer did was remarkably important, of the level that very few scientists achieve. It becomes baked into our textbooks. It underlies important therapies in medicine. And the really incredible thing about Dr. Pillemer's work is that he did that. Very few of us in science do that. And then he did it twice. So the first area that he contributed in was in the study of bacterial toxins in the 1940s. For example, tetanus toxin. And the preparation, he developed the approach for developing non-toxic toxoid preparations of those toxins so that they could be administered to individuals in vaccines without their toxic effect, of course. And this laid the foundation for developing the DPT vaccine, which I hope that all of our children are receiving these days. It's hard to know with the vaccine doubters. But that's been an incredibly important impact on health internationally over the decades. And then he discovered the alternative pathway of complement, as Dean Gerson mentioned. At the time, a revolutionary and paradigm-shifting discovery that continues to have significance in immunology and medicine. And it is a very special pleasure today to have members of the Pillemer family in attendance, including two of his three sons, Stephen, one of our Case MD alumni, and David, a psychologist and researcher, along with their wives Helen and Jane. Thank you so much for coming. And I had the pleasure also of meeting not only them, but their brother Carl last year in a Zoom meeting. Carl's unfortunately out of the country and unable to attend. But it's been wonderful getting to know them through the creation of this professorship. And Dean Gerson wanted me to mention that about the creation of the professorship, and actually it echoes what Dr. Greenspan said. The thing, it's really special to create any professorship, really, but it's especially special to create professorships in the name of our leading faculty scientists who have created the most incredible advances, and to honor them and what they've achieved. And so the department was able to obtain resources that could be devoted to the establishment of a professorship, and we chose to use those to help develop the Pillemer Professorship. So finally, I'd just like to say a few words about Dr. Pizarro. She's going to have some other introducers and some things to say for herself, but just to give a brief review, she's also a Case alumna, having received her bachelor's degree here, her PhD from Loyola, and a postdoc at USC before she moved to University of Virginia as a faculty member and rose to professor with tenure there, before coming here to CWRU, where she's now a professor of pathology and the inaugural Lewis Pillemer Professor of Pathology. She's made numerous seminal contributions in the field of mucosal immunology, particularly in the field of inflammatory bowel disease, using both murine mouse and human models. She'll say more about this, but many important papers, including a recent one in Cell, really one of the top journals in science. Many grants. She currently is working as principal investigator or multi-PI of 2 program project grants and 2 R01s, multiple other grants as collaborator and co-investigator, and importantly, as Dean Gerson mentioned, the multi-PI with Fabio Cominelli of our Case Medical Student Summer Research Program T35 grant from the NIH. Numerous awards and honors. I will only just mention a couple. The 2019 recipient of the Madame Curie Award from the Crohn's and Colitis Foundation, the 2022 Women in Science Award from the International Association of Inflammation Societies. She's provided leading national and international service on many advisory committees. The Crohn's and Colitis Foundation, she's been a big leader in that organization. NIH, numerous journal editorial boards, numerous sessions at meetings or other venues that she has chaired or moderated. And I would be remiss if I didn't mention her incredible record as a mentor, who's highly committed to her mentees, to all her mentees and their success locally, but also, has given much local and national contribution to advancing women in science. So I'm grateful, Teresa, for all your contributions, and I congratulate you on those accomplishments, and now as this award as the inaugural Lewis Pilmer Professor of Pathology. Thank you.
I will make a side comment that there are only a few occasions in which the chair of a department gets to inform the dean of the selection of chair candidates. These be two. So again, with respect for Dr. Harding's good judgment. So it's now my pleasure to pre-introduce Dr. Pizarro with the introduction of Dr. Chuck Parkas, who is the Charles V. Weller Professor and Chair of the Department of Pathology at the University of Michigan Medical School, for a few comments, and then we will get to hear from Dr. Pizarro. Thanks for joining us.
Thanks. So good evening. And it's really delightful to be here tonight to celebrate the endowment of the Lewis Pilmer PhD Professorship in Experimental Path and the installation of Teresa as its inaugural recipient. I'm really glad to be able to celebrate this with Teresa, who I've known for about 30 years. I remember first meeting her when I received the Crohn's and Colitis Ari and Ida Crown Award back in 1994. And here she is, kind of fretting about writing her first grant back then. And we've stayed in close contact over the years at many meetings, many study sections, and also given our complementary interests in mucosal immunology. Through these many interactions, I've become close personal friends with Teresa and her family and have followed her career with great interest. Early on, she was part of a team that identified and characterized, as Cliff alluded to, one of the very first mouse models that developed Crohn's disease-like characteristics involving, as some of you may know, likes the end of your small intestine. And she has gone on to make very significant contributions towards characterization of a family of inflammation-induced proteins or cytokines in the interleukin-1 family, and how they play an important role in chronic intestinal inflammation. During her work as a postdoctoral fellow, she focused on dissecting the role of these IL-1 proteins, and there's actually a receptor antagonist to those proteins called IL-1RA in both inflammatory bowel disease and experimental models of mouse colitis. As an independent investigator, she published the first papers reporting the importance of related family members called interleukin-18 and interleukin-33 in the pathogenesis of inflammatory bowel disease and these chronic models of mouse inflammation. She described in a seminal paper in 1999 in the Journal of Immunology expression and localization of this interleukin-18 protein in the gut and its upregulation in association with Crohn's disease. She then went on to publish in the National Academy, the Proceedings of the National Academy of Sciences, observations that linked the dysregulation of this other interleukin, interleukin-33, and its receptor in inflammatory bowel disease, and then extended that to mouse models of colitis. And this was followed up with two important papers on the role of these interleukins in the repair of wounds. I'm a gastrointestinal pathologist in poorly healing wounds in the intestine is one of the reasons that brings many people with inflammatory bowel disease to the hospital. And she published these in top-tier journals, PNAS and Journal of Clinical Investigation. And Cliff alluded to a really amazing paper that just came out in Cell, and that involved Teresa's team making some really cool observations on a protein called gastromin B, which are known to induce inflammation-induced death in the immune cells that are important in regulating response to inflammation. And she found that gastromin B not only regulates that, but also regulates the proliferation of epithelial cells that cover wounds, as you see in inflammatory bowel disease. And that this plays an important role in the healing process. The importance of this was further highlighted by showing that there are genetic variants of this protein that are known to be associated with both asthma and inflammatory bowel disease. So really a fantastic study, and she beautifully summarized the state of knowledge on this area in a Nature Reviews in gastroenterology and hepatology, specifically focusing on this really fascinating group of proteins and the clinical implications of this and the need for more research. So while with these many significant contributions, it's not surprising that Teresa's research has been extremely well funded and successful by the NIH and the foundation, and foundation grants, particularly from the CCF, over the past 29 years. And she currently, as Cliff alluded to, has 8 active grants. Many of my interactions with her have been through highly active involvement with the Crohn's and Colitis Foundation of America, and in that capacity, she's also received many prestigious awards for her work. And as Cliff mentioned, she received the CCF Madame Curie Award back in 2019, and here she is trying to make a smile, I guess, right? Her tireless service on study section has been exemplary, and I've been impressed with how many grants she can review in so little time. And on top of that, she has, in addition to the Crohn's and Colitis Foundation, she has been very active at the American Gastroenterological Association and many, many NIH study sections, editorships, editorial boards, and other areas. And from these accomplishments, it's really not surprising that she speaks all over the world. I think I counted on her CV over 120 times, and it's helped organize some of the best meetings that I've ever attended. Her impressive teaching record includes more than 70 junior investigators, many who have gone on to successful scientific careers. And this is really something that we in academic medicine really take pride in seeing our trainees go on to do great things. I would point out that Teresa is very passionate, as Cliff mentioned, in supporting the development of women scientists, and as such is a member of many important committees in this area. And through all of the time that I've known Teresa, some of the most special memories that I can share are all the great times that we've had in very fantastic venues. I remember one meeting a number of years back in Tuscany that was held in an old monastery with fantastic science and banquets, and ended up with a group of us having drinks and hors d'oeuvres in a fancy restaurant or club overlooking the Duomo in Florence. I mean, really unbelievable. Similarly, we've had many great program project-related scientific meetings when she was at UVA and here. And I'll come to the end here with just another picture of one of the great meetings we were at in Vegas, and I was fruitlessly trying to teach Teresa the art of video poker, and I think she still needs practice. So, Teresa, I'm delighted that you are being installed today as the inaugural Lewis Pilmer PhD Professor of Experimental Pathology. It's been very special to follow your career as a colleague and friend, and I look forward to your ongoing success. Congratulations on this well-deserved honor. And it's my pleasure to introduce Ozma Nusrat, who's the F. Peyton Rouse Professor and Director of Experimental Pathology at the University of Michigan Medical School, who has also known and followed Teresa's career for many years and is a world's expert in the regulation of barrier function and intestinal inflammation and repair, and has some very appropriate remarks. So welcome, Ozma.
All right, now that I'm coming after a number of people, I might have some repetitions, but I'll try to make them as very entertaining, much better than all of them. So it is truly a pleasure to participate in this very joyous and highly deserved appointment of Teresa Pizarro as the Louis Pilmer Professor of Experimental Pathology. I've known Teresa for over 2 decades, and I'm not telling you the exact amount because then you'll know how old I am. And I have really enjoyed seeing her academic journey. And as has been pointed out, Teresa is a native of Cleveland and graduated with a bachelor degree from here. And you should be really proud. I mean, she left here and then came back here, and she's doing so fantastic. And now she has this endowed professorship. So that indeed speaks very well of an institution. Just to highlight, Teresa, as Chuck had mentioned, is a mucosal immunologist, and her work has made absolutely seminal contributions in identifying an inflammatory signaling through the IL-1 family member of cytokines, and she identified other family members that play a very important role in pathogenesis of inflammatory bowel disease. So again, I'm coming number 3 or 4, but I'm going to again point out it is really remarkable. She has been continuously funded through her scientific journey by the NIH and private foundations. I figured I'd at least show some pictures of the young Teresa as a graduate student in cell biology and transplant immunology, and then as a postdoctoral fellow in California. And in spite of being on the West Coast, sunny, she came back here to the East Coast. So I'm very impressed. And I met her daughter today, Marissa, and I hadn't seen her in a while, and she's a replica of what Teresa looked like when I met her initially. So when she comes up, you can look at her, and that's what Teresa looked like. Teresa's success is complemented by very high-profile publications, and as has been mentioned, her seminal papers in PNAS proceedings of the National Academy of Science, JCI, and most recently Cell. And for those of you who don't work in the scientific arena, Cell has an impact factor of over 30, which is like unbelievable. So congratulations. She has, in her abundant free time, a big family, and done all these fantastic contributions, has contributed to the education of undergraduate, graduate, and postgraduate students. And in fact, she has mentored over 70 young investigators, and she's, as has already been mentioned, she's very, very passionate about supporting and cultivating careers of women in science. So Chuck already stole this picture from me, and so I'm going to show it again. But Teresa received the Madame Curie Award from the Crohn's and Colitis, as well as she was awarded from the International Association for Inflammation Societies, awarded a Woman in Science in 2022. So just to recap, she has remarkable track record funding of absolutely innovative science, of supporting the younger generation, our future scientists. And it has been such a pleasure to have known her through this journey. And it's a real honor for me to be here today And we drove up. I said, I'm not flying. I'm just going to drive. I'm in Michigan. And it was actually a lot of fun, and I might come back again. So anyhow, I will now pass on the stage to Marissa, who is Teresa's oldest child, who looks just like her, and is currently in her first year at Harvard Business School. And she's going to share you some exciting stories about her mom. And with that, I'll give her the stage.
Hi, everyone. I'm super honored to be here and be able to talk on my mother's behalf. From a more personal point of view, you've already heard what an impressive scientist she is, so I'm excited to talk through what I know of her as her daughter. So, as a kid, I used to think that my mom was superhuman. She is cool and fashionable. She is a boss lady at work, as you guys have previously heard, and she is a loving and thoughtful mother. Now, as an adult, I realize that my impressions as a child were not that far off. My mother is an extremely impressive person, not just in her accomplishments at work, but how she shows up for everyone with her love and dedication. Over the years, I have picked up many life lessons from her, which I believe have enabled a lot of her success. So now I'm going to share a few of the sibling-approved lessons with you today. So, lesson number 1, it is good to have high expectations. Anyone that knows my mom knows that she has high expectations. She proudly flaunts her Tiger Mom status, explaining that on a report card, an A is just acceptable, and a B actually stands for bad. But these high expectations that my mom have are because she sees high potential. And trust me, you want Teresa Pizarro backing you up when you are trying to achieve them. Okay, so lesson number 2, details matter. My mom is someone who pays attention to detail. From making sure that every piece of the party paraphernalia is matching the theme, as you guys can see in this picture here. She's like that with every single party. To also helping me glue together hundreds of toothpicks for a school project. My mom thinks that even the little things should be paid attention to and taken care of. But perhaps even more importantly, she pays attention to the details in conversation. She has an unreal ability to remember even the most minute details of any conversation. Even now, it surprises me how she will remember my sister's friend's roommate's boyfriend's name, and also how long they've been together. But her ability to remember these details are how she shows that she's really listening and she cares about what you have to say. Okay, lesson number 3, loyalty is key. My mom is fiercely loyal, and she values those who are loyal to her. We always have a saying that you don't mess around with the cubs or you get the anger of the mama bear. A couple of ex-boyfriends may still have to watch out. But this loyalty is more than just protectiveness. It manifests itself in an unyielding support and advocacy. She is someone who shows up, whether it's a graduation, a school play, and a sports game. There's no greater power than having my mom in your corner, and that's on top of everything that she's doing at work. All right, lesson number 4. Don't worry, we're getting to the end. You should wake up every day excited about what you do. My mom is extremely passionate about her job. Seriously, I've never seen someone get so excited about an artfully labeled model or get so absorbed in writing the perfect abstract. I've grown up seeing what it looks like when a person is genuinely interested in their work and wants to talk about it, even at the dinner table. My siblings and I had heard about the NIH impact factors and aisle 33 before we went to the first grade. And the Sand Mouse, yes, Bobo. That passion is something that I will continually strive for in my own work, and it's one of the things that I admire most about my mom's career. Okay, there's a slide missing, but this is the last lesson. Finally, one thing that my mom has often told me, lesson number 5, is if you're good, you don't have to say it, people will notice. My mom has always been someone who has let her work speak for itself. And while she might not have always gotten immediate recognition, I am so incredibly happy and proud that she is receiving some of that recognition today. Congratulations on this chair, Mom. It's so well deserved, and it couldn't go to a better superhuman than you. And without...
Okay. I know you guys are all starving by now and want to get to the food part of it, but Chuck, really, that's the only picture we have together at the slot machines in Vegas? I mean, like, it's fine. Okay, so I'm very excited that you guys are all here today. I'm very grateful to the Pilmore family for attending the ceremony and for all their support and contribution for the chair. I'm so happy that Chuck and Ozma drove down from Michigan, because not only have they served as role models for me, but they've really been true friends throughout 30 years of knowing each other. So I'm going to do an abbreviated timeline as well. I don't have a pointer, but I'm going to go through, and I was actually born right here in Cleveland, right down the street at Rainbow Babies and Children's. My parents were both doing their medical residencies, my dad in surgery, my mother in med peds, and shortly after they graduated, we moved back to their home country of the Philippines. We returned immediately back around 4 years later, and I grew up in Solon, graduated from Solon High School, and then I went to school at Case Western with the promise from my parents that I was allowed to leave, I was allowed to live more than 30 minutes away from home once I graduated from college, which I did. I ran. So then it was about that same time in 1986 that two scientists, Rita Levi-Montalcini, which again I have this connection with Italy, I guess, and Stanley Cohen discovered nerve growth factor. And I was quite interested in that because I had done undergraduate research with a guy named Joseph Fagan in the Department of Psychology. And Dr. Fagan really pioneered the development of understanding infant IQ and how infant IQ later on associates with later achievement, academic achievement, and cognitive abilities. So it was quite intriguing to me. And so there was a young investigator named Tony Castro that was at Loyola University of Chicago that trained with Dr. Levi-Montalcini, and I headed that way to Loyola. I stayed at Loyola from 87, I guess, to 93, and published 3 first-name authored papers there. My thesis primarily focused on looking at cardiac allograft rejection after transplantation. But really, one of the most compelling things happened, or life-changing events happened to me a couple of years before graduation in 1991. And it was this particular meeting that I attended. It was the first meeting that I submitted an abstract. It got an oral presentation. So my advisor, Elizabeth Kovacs, was like, yeah, I think I'll let you go to this. So it was a big deal that as a graduate student, I was allowed to go to this meeting. It was the first time in Italy. I was very excited to go. And I met this guy. And this is a photo, actually, true story. This is a photo 3 days after I met this guy, Fabio. I got the picture years later from his mentor, Charles Dinarello. Do you think, and I thought, does he like me? Do you think he likes me? I don't know. Like, so, you know, in Fabio's all his obvious ways. If none of you know, this is my current husband. No. And actually we celebrate 30 years next year. So anyway, this is the second half. Truly life-changing. So this is the second half of my career pathway. I entered a postdoctoral fellowship at USC. During that time, I wrote and obtained my first award, a research fellowship award from the Crohn's and Colitis Foundation. I then got recruited to the University of Virginia as assistant professor, and then shortly thereafter, I got my very first NIH R29 First Award. And for those of you guys that don't remember what that is, it's very similar to, I guess, like what a new investigator R01 is, but these were R29 for first grants coming out. So in 2004, I became associate professor, and back in those days, tenure and getting your associate professor, getting promoted were unlinked to each other. And then afterwards, I moved to and got also recruited by John Lau at Case Western in 2009. And then just 2014, I obtained a professorship with tenure. And then again, I'm very honored that in 2021, I was awarded the Pilmer Endowed Professorship. So what I want you women to look at here is the timeline of this. So this is 1995 to 2014. And for those of you who do the math, that is 19 long years, which on average, I would say it usually takes someone about 8 to 10 years to get from assistant professor to professor with tenure. And so what happened between these periods? Okay. So, so one thing I'd like to point out is this. You know, I always thought I wanted to play with the boys. And I never showed up to work with my kids until we had one child that was born with a congenital defect. And basically, you know, I said, forget this. Like, why not take the time off? And so during those periods, and this is why it took me so long to get from assistant to associate to full professors, for each child, I took 1 year off my tenure clock, which, again, more about this later, okay? So I'm not going to go, actually, because I know we're running short of time, and I'm just going to go briefly. I was asked, what do you think your most seminal contribution is to the scientific community? It's obviously this latest paper that I had in Cell 2 years ago, or it's now last year. And you know, I'm not going to go to these details because I think what I have to say on the other fronts are much more important. So guys, read the paper if you're interested in it. If you want the slides, it's a very compelling protein. What I would like to point out is this. Okay, I've had a lot of support from people here. I want to point out that we have another Chuck. We have a very great meeting planned at the beginning of May. This is an association with PPG that George Dubiak heads, and with my colleagues Derek Abbott and Sam Shao. We have great people coming into it, but what I wanted to point out about this, and again, I have the same picture, I'm sorry, of Mr. Lepeau. Someone's got to change that on the internet. But one thing I wanted to say is the connection that I have with Louis Pilmer, in that he did discover piperidin, which is a plasma glycoprotein that activates complement. It's an important component of innate immunity. This protein binds to bacterial cell walls and dying human cells. That stabilizes other proteins that form actually this membrane attack complex. And interestingly, this assembly of this MAC leads to pore formation of cell membrane of target cells and eventual cell death and cell lysis, which is very, very similar to what the role of gasodermins are, this previous paper that I had in Cell. And so I actually did look it up on the internet and looked up at PubMed to see if there's any association between piperidin and gasodermins. And so Derek, I guess this is our next project. So I haven't found anything, it's unpublished, so this looks like a great area. Okay, so as you know, one of my latest projects, and we just received funding from the Crohn's and Colitis Foundation, and this is the first grant I've received that is actually a clinical investigator grant that looks at the impact of the microbiome on sex differences in IBD. However, there are several GI-related diseases that show sex differences. And here, what I'm showing here is the delayed onset of colorectal cancer in females versus males, and the decreased incidence of esophageal cancer in females versus males. So I'll ask the audience, what other situation do you guys know of with delayed onset and decreased incidence comparing females and males? If you answered the sex-gender gap in academic medicine, this is absolutely correct, and I'm very passionate about this. And I wanted to point out that the rates of achievement and retention of women scientists in research still in 2023 shadow those of our male counterparts. Decreased salaries of females versus male academic physicians in some subspecialties. I just read a paper where they showed that in the field of ophthalmology. We all know about the delayed time to promotion and tenure in females compared to males. I think I'm a good example of that. And there's this recent report in Cell that showed persistent disparity in manuscripts authored by males versus females. So in Cell, the journal that I just published in, 17.4% were submitted by females. Those are not accepted manuscripts. Those are submitted. And so, this shows that we need to step up to the plate. I wanted to point out this book because it's been circulating around female scientists. This was published just a couple months ago. It's called The Exceptions, and it recounts a story of 16 female scientists led by Nancy Watkins. And basically, this group forced MIT to publicly admit to have been discriminated against with its female faculty for several years. So what I wanted to point out here is, although their story was written or, say, recounted or occurred more than 2 decades ago, this still occurs now. And while we're moving in the right direction, and again, with the help of Stan Gerson and Cliff Harding, who are big promoters of DEI, there still remains these issues to be addressed. And we all, as a group, females and males alike, have to be cognizant of this. So these are all my trainees. I want to thank them. These are, I would love to have all you guys up here, but these are some of the pictures. The middle picture are the most recent lab members. I want to provide a special shout out for 2 groups. The first is the Italians. They really did provide a lot of support for me. I've had several postdocs, graduate students from several institutions in Italy, and they've been the backbone of my research program, not only here at Case, but also at the University of Virginia. I'd also like a special shout out to my right-hand man, Carlo DeSalvo. And what Marissa said, your ability to serve as a loyal colleague all these years, I really do appreciate your help with all we do in the laboratory. So here we go. So what I'd like to point out, oops, how come that doesn't work? Francesca? All right, I had all the names coming up. This is my group, and every single one of these women are here tonight. This is my female support team, and all these women that I want to point out are boss ladies, okay? They're going from vice president to owning their own companies, to physicians, cardiologists, dermatologists. They're just boss ladies that manage their personal lives. Every single one of these women on here are mothers. There are educators, they're teachers, and I want to give you a huge shout out because I could have not gotten to the place I am. Biz, Penny, Kristen, keeping Anea while I was going to meetings and, feeding him. Penny, the only downside that you ever had, you didn't learn how to cook Filipino food, okay? which Anea asked for. I couldn't end this without thanking my parents. They're sitting here in the front row. They are 90. They've truly served as the most important role models in my life, especially my mother, who balanced everything, career. She had an active medical career, and they had a joint practice in Solon together. They celebrated their 90th birthday, both of them, about 2 months ago. And so really, I love you guys, and you really did. I think the reason that I'm the way I am, that my kids are the way they are, is because you guys you guys were such great role models for all of us. Final slide, I can't go without thanking my family, especially Fabio, who has been my rock. I also do not think that I could have achieved what I have now without Fabio. He understands when I have NIH deadlines. He understands when I have study section, and I'm staying up all night, and he, takes care of dinner. The left picture actually is during his inaugural chair ceremony, and that in 2009, about 14 years ago. The middle photo is our 25th anniversary, and this is our summer vacation. I'd like to thank Marissa, Francesca, Chiara, and Nea. You guys, I could not ask for better kids. I think you have, lived the life through two scientists. I want to also point out a funny thing. It's something. None of my kids, 4, I've had 4, none of them went the route of science, okay? 0. And so I asked them, I go, so was it me and Babo? Was it us? And they were like, yeah, it was you. So thank you guys. Let's party and celebrate, and love you guys.
So now we do, in fact, get to party. We got to take some pictures of these chairs. We're going to let the folks sit in these chairs briefly here, and then we're going to go out while you guys all party. We'll take some individual, academic, family pictures, as many as we can get behind the chair, not in front of the chair, behind the chair. So think how proud the moment is for Brian and Teresa, but think how proud this is for the School of Medicine. The passion we've seen here, the accomplishment, the dedication is profound, and it's a joy for the dean to be here and to allow this to take place. So I hope you all enjoyed it as much as I have. These are 2 remarkable people. Congratulations. Make sure they sit in the right chair. All right. This one says, Brian Arnold Cobb, PhD, Michael Lamb, Professor.
Cliff, I need a bigger office.
They're all the same size, Brian.
Arnold, PhD,
Not yours.
the Louise Helger, PhD Professor.